Welcome to factoring complex difference of squares. So this in essence isn't much different than what we worked on in the previous lesson. However, it is a little bit more complicated. So for difference of squares, we need two terms. One needs to be positive, one needs to be negative, and they both need to be perfect squares. And that's exactly what we have here. So remember, when we factor difference of squares, we take the square root of the first term minus the square root of the second term, and all that multiplied by the square root of the first term plus the square root of the second term. So we're going to do exactly that. So we're just going to use another set of brackets here. So square root of the first term, and of course it doesn't matter if you do the minus or the plus first, and square root of, right? So of course that's x plus 5 times x plus 5. And now we need to simplify. So we'll add what's in brackets, and we get x minus 2 times x plus 12. Okay, next one, very similar setup. So we'll take the square root of the first term minus the square root of the second term. And now we'll simplify. Now what we have to do here, normally when we factor, we're used to looking for the greatest common factor right away, but now we have to look at it afterwards, So if you look here in this first binomial, you can see a GCF of 2, right? Because 2 divides evenly into both of these. And you can also see a GCF of 2 here. So what we can do, and you can do this in one step, but I'll show you in both. Right? So we can take, so you don't have to take out the 2 separately, you can take out the 4. But then our final answer looks like this. So if we multiplied that, right, 4 times m minus 2 times m plus 6, and multiplied this, we would get the same equivalent expression. That's what we're doing here. Now this one, what we have to do then is turn it into a difference of squares. So this here, and this is from Foundations in Precalculus 10, is a perfect trinomial square. So c plus 3 squared, and then we're going to do the exact same thing. And don't worry too much about the order. We don't put negatives in the first term, and that'll come up, I think, fairly quickly here. Don't worry too much about the order, and that's what we're looking for. So we want to remember to always look for that GCF. Okay, so moving on. So now you can see I have the perfect trinomial square to the right, and that's just going to change things a little bit because of our brackets. So we'll just start here, square root of the first term minus the square root of the second, square root of the first plus square root of the second. So now don't forget, when we have a negative, it's like we have a -1, and we need to distribute that -1 to both terms. So a minus b minus c times a plus b plus c. Same thing. So notice, right, how I have two m plus 3's. So it's my positive and negative that go there. 6 minus m minus 3. And here's our example. We have a negative here, and it's fairly minor, but it's not considered simplified if our first term is a negative, so we have to pull out that negative. And there we have it. So once again, these ones are a little tricky, so we have to pull out that -1. And then factor that. And then simplify. quite see everything. Sorry about that. It's hard to get it in there. Now, I know this is going to be a little tricky, so I'm going to, I think, just expand it a little bit so that I can get it to fit. Yeah, just do that. I think that'll work. So once again, we just have two perfect trinomial squares, which when put together give us a difference of squares. So same concept, bracket, square root of the first term, minus square root of the second, square root of the first, plus square root of the second. And there we go. So we'll add, so x minus x gives us nothing. When we subtract a negative, 2 minus negative 5 gives us 7. And then going over here, we have 2x minus 3. It's definitely not as nearly as complicated as some of the other ones. And we just have two more for practice now. So now we have a numerical coefficient here, so we'll take the square root of that, minus do a little bit, and I'm not super picky about steps here. You just want to take your time to watch that. You remember to follow all the rules from grade 9, basically, is where we are here. So simplify again, 2n minus 10, 4n plus 4, and then we have to double check our binomials and make sure that there isn't a GCF, and there's a GCF in both. So we'll take a 2 out of this one, and a 4 out of this one, multiply them together, and that's our simplified answer. And the last one, which I know is not going to fit unless I make it super small, so you might want to just take a look at the notes. So we'll go here, square root of the first, minus square root of the second, which I think I'll just slide it over for you. Square root of the first, plus the square root of the second. Oops, that's an m. And then we'll go back here and we'll simplify. 10m minus 15 minus 6m plus 2. 10m minus 15 plus 6m minus 2. And then we'll add them together. And that's it.